Hi, I'm Mr. Slesher from the Quantitative Reasoning Center. Welcome to your homework. Today we're doing section 7.4, problem number 19. In this section we're doing integration by partial fractions. Seems a little daunting maybe at first glance, but you break it down, they're really pretty simple. So let's go ahead and jump right into one. Okay, this number 19, we've got x squared plus 1 over x minus 3 times x minus 2 squared. Okay, so this is a case 2 integration by partial fractions. In this case, we've got, of course, you want a px over a qx, and in case 2, qx is the product of linear factors, some of which are repeating. That was repeating. So we can just follow the example in the book, the way they show to do this one. And we could rewrite this as integral a over x minus 3 plus b over x minus 2 plus c over x minus 2 squared. And of course I'm going to have a dx times everything out here when I get ready to actually do the integration. So now the only hard part is I've got to figure out what a, b, and c are. Okay, let's do something here. Let's rewrite this. We can take this and get a common denominator and add them up. Sounds simple? And if I do that, if I get a common denominator, I'm actually going to use this as my common denominator. So x squared plus 1 is going to equal a plus b plus c times some stuff. Okay, just follow me on this. Okay, so I'm going to multiply this factor here by x minus 2 squared. I'm going to multiply this one by x minus 2 times x minus 3, and multiply this one by x minus 3, top and bottom in each case. Okay, so what I end up with is x squared plus 1 is equal to a times x minus 2 squared plus b times x minus 3 times x minus 2 plus c times x minus 3. Okay, and I'm sure you know enough about fractions to know how this works out. Okay, so now this is going to make it a little bit easier to find a, b, and c. First of all, let's set x equal to 2, and that should now allow us to solve for c over here. So if we make x equal to 2, that gives us 4 plus 1, which is 5. Nice 5. Okay, if x is equal to 2, this whole thing is 0. I got an x minus 2 here, so if x is equal to 2, that whole thing is 0. And all I'm left with is c times 2 minus 3, which is minus 1. So this is equal to c times minus 1. So therefore, I know that c is equal to negative 5. Okay, now let's do another one. Let's let x equal 3, that'll allow us to solve for a. Okay, so for x equal 3, that gives 9 plus 1, 10, is equal to, okay, I've got 3 minus 2, 1, 1 squared, still 1, that is equal to a, plus, again, this one goes away, that one goes away. That one was simple. Okay, so a is equal to 10. Now, to solve for b, I'm going to have to do a little algebraic sleight of hand, which really isn't a sleight of hand at all. It's pretty simple. I notice here that if I were to multiply this out, I'm going to have several x squared terms. Okay, I've got one here, I've got an x squared over here. If I were to multiply this out, I'd have an ax squared. I would get an x squared here, and I'd distribute that a, and I would get an ax squared. And here I would multiply this out. If I FOILed that and then distributed the b, I'd have a bx squared. I have no x squared terms here, so nothing to worry about. So therefore, 1 has got to equal b plus a. The coefficients, they have to equal each other. They just have to. A plus b. So, I already know a is 10, so that leaves b is equal to -9. b equals -9. Okay, now I know a, b, and c. This problem's getting simpler all the time. Let's get rid of this. Now, since we know a, b, and c, we can rewrite our integral. So I have the integral of a, which is 10, over x minus 3, plus b, which is -9. Let's go ahead and just make that a minus 9 over x minus 2. Let's put some parentheses in there. And then c is -5, so I've got minus 5 over x minus 2 quantity squared. And of course, I've got a dx times this whole mess. Okay, now I got a bunch of simple little integrals here. We all know this one. This is 10 times natural log absolute value x minus 3 minus 9 natural log absolute value x minus 2. This one is just the reverse power rule, keeping in mind that this is actually x minus 2 to the -2 times 5, so I'll end up with a plus 5 over x minus 2. And then I need a plus c out there. Alright, integration by partial fractions. There's several different cases in the book. This is the one you're probably going to see a few times, so I thought I'd explain one to you. Have any questions, come down here and see us in the QRC in Fairchild Hall, first floor, in the A section. Take care. Bye.